Hello there. We are going to spend some time together now to explore the signals and actions of Cerebral, and we're going to build a small application. I'm going to use a boilerplate I built for Webpack and a node with Express, doing some proxying and stuff, just to create a really nice workflow. So I encourage you to check that out. So jumping into the terminal, in this project we have to install some dependencies. And of course we need Cerebral, which is going to control the state changes of your application. So that is kind of like the controller layer. We also need a model layer, and we are going to use Cerebral Immutable Store for that, but you can choose other model layers if you prefer something else. We also have to install a view layer, and that's Cerebral React. So we're going to use React here for our UI. And that basically consists of some mixins and a wrapper for your application so that we can trigger signals and get state from Cerebral. So let's see, clear and fire this up now. This runs on localhost 3000 and it should state hello world here. Let's see, there it goes, and really nice. And on the right side we have the debugger, and we also have our console. So let's jump into some code. I won't go through the whole file structure here, just focus on the app here. This is where we're going to build our application, and I've structured it like something well, it's one convention. If you want to build a really large application, this is one way of doing it. You have an actions folder, a components folder, a factories folder. We're going to look at that soon, and a signals folder, and you have your main file. Currently it just renders this app component to the DOM. Okay, so the first thing you want to do is to create a controller. So let's create a new file here, controller.js, and we have to import Cerebral, which I just called the controller, and we have a model, and we import that from Cerebral Immutable Store. Okay, and we need to instantiate our model, and we do that by passing in an object. So all the state of your application will be inside this one object, and we want some state called isLoading, which we're going to load some stuff when we fire up the application. We're going to load a user and some to-dos. And so I will set isLoading to false, and the user has some data, and it can also have an error. The server currently only gives success responses, but I'm going to code the scenario so that it would be handled. Okay, and we're also going to have some to-dos here. So let's have data and error also here. Okay. And you can structure this however you want, what makes sense to you. This is just one example. And if you have lots and lots of state and you're worried about putting all that into one object, you can easily split this up into different files. So you would have like namespaces, for example, home and admin, and you could have a file called admin and have lots of state inside there. So it's easy to split this up, but it's very beneficial to have all the state in one object, because then you have less places to look, and the structure of your application will be a lot easier to reason about. So what we want to do is instantiate our controller by passing in the model, just like that. Okay, so now we have our controller, so let's expose it to our application. And we do that by simply importing it from controller.js. And we also want to import, let's do that above here. We want to import the container from Cerebral React. So the container is a wrapper component that can get the controller and the main component for your app. And that will render your application, exposing the controller to all your components so that you can grab some state, and you can also trigger signals. So let's save that now and see if everything works. And it does. That's great. Okay, so what we're going to do now first is to grab the user. So let's jump into our app and start defining some UI for this. Or maybe we should just grab the state, because then you can see, yeah, let's do that, because then you get to see the great insight you get in the debugger. Okay, so what we want to do now, we want to create a signal that grabs the user. And this signal should be triggered when the application mounts. So we are going to go into our signals folder, and we are going to create a file called app mounted. So this indicates when this signal triggers, and it triggers when the app mounts. And what we do here is that we export an array. And the reason we do that is because if we now jump to our main file and we import app mounted from signals app mounted, we are able to create a new signal called app mounted, and we can use the spread operator. So this means that all the items in this array will become arguments of this signal. So for example, if we inserted a set loading action here, that will be the same as saying set loading here, not using an array. Okay? So the spread operator is great for doing this stuff, and it's also great for doing other stuff. Like for example, if you wanted set loading here and you wanted to use a group of actions from somewhere else, you could just say other actions, and that would be kind of like be merged into this array. So the spread operator is really great. But okay, we actually want to just run this signal, and we want to run this action called set loading. So let's go into our actions folder and create this action now. Set loading, and this will be just a function. Let's export default set loading, and this action takes some arguments. First, it takes an input, and since this is the first action in the chain, that input could only originate from triggering the signal. So when you trigger the signal, you can pass some data, but we're not going to do that in this case, but that data would be available on the input argument. Then we have our state argument, and this is kind of like your endpoint to the model layer. This is where you can change and get state. And that's exactly what we're going to do here. We're going to say state set is loading to true. Okay? And that's basically what we're going to do for now. Let's save that. Let's import it into our signal. Set loading from actions, set loading JS. And now we have that inside our signal. And let's save the signal here. And now we just have to trigger this signal. So component will did mount. We're going to say this.props signals app mounted. But these signals aren't exposed to all components by default. We have to tell this component to grab this stuff from our controller. And we do that by importing a decorator, as we're using a class here, from Cerebral React. And we can just say Cerebral and use an object. And if you do it like this, we actually have access to the signals, but we can also use this to define what state we want to grab. But let's just do this first and see what happens when the application fires up. And as we can see, a signal was triggered, app mounted. It triggered an action called set loading, and it set the is loading state to true. Okay, so now we know this actually works. So what we want to do now is grab that state from Cerebral and insert it into the component. So there are two ways to do that. We can put an object here and say is loading, and we grab that from the path is loading. So the first key here will be the key that you use inside the component. This could be whatever, it could be foo. And the value is an array pointing into the state tree. So is loading is at the top of our state tree. So we just use is loading. Okay, so now that is yes, sorry. And the other way to do this would be to like that. We could say we could use props, and I think we have to do it like that. Return something like that. So we could use a function instead where you have the props available. So you can have dynamic state fetching. But let's not go into that. Let's just grab the state normally. And when we now render this application, let's change it a little bit. We want to this.render user, render user. We want by default to say no user, but if this props is loading, so the state will be available on the props property. If it is loading, we are going to return loading user like that. And if we have, if it's not loading, but we have some, well, let's try this first. Let's see how it looks. So we fire up the application again, and now it says loading user. So that's great. And what we want to do now is to actually grab the user. So let's move into our signal again. And what we want to do here now is to create an action that actually grabs a user. And the way we're going to do this is because we're going to grab two different things. We're going to grab the user and we're going to grab the to-dos. And the only difference between these two is the URL. So what we're going to do is create something called a factory. So let's just see how this is going to look. First of all, we're going to use an array here, and that is to indicate to Cerebral that this is asynchronous. So instead of defining it being asynchronous inside action, we do it in the signal. And that is because the signal should give you all the information you need to understand the state changing flow of your application. It should, you should not have to go into the implementation details of actions to understand the flow. So if we say get user, this is what we want to write to grab the user. And to do that, we have to create a factory. So this set loading action here is just a function. But we are now going to call a function that should return an action. And it should use this user argument here as part of that action. Okay, so first we want, of course, to use something to grab the user. We have to talk to the server. And Cerebral has something called services. So let's check that out first. First of all, I'm going to install SuperAgent, which I like to use. You can use whatever Ajax library you want. But we're going to use SuperAgent to talk to the server. Let's see here. There we go. Let's fire up again. Oops. And let's move into the controller. So now we have the model, but we can also define services. And this is an object that will kind of like inject utils into your actions to keep them pure. So in this case, we're going to use SuperAgent, request from SuperAgent. Okay. And we pass that as a second argument to our controller. And what this allows us to do is to access these services inside our actions. And we will see an example of that very, very soon. So in our factories folder, we're going to create a new file and we're going to call that get. And this is going to export a function, and this function is going to take an URL, and we are going to define get, and we are going to return that get function. Okay, and this is the actual action. So this will get the input, the state, and since we are going to give some output here, getting stuff from the server can either result in a success or an error. So we're going to use an output argument, and as I said, we have these services which are injected into each action. So what we're going to do now is use our services request, and we are going to request the URL, and when we get an error, we are going to say if error, we're going to output to the default error path, and we're going to output the error, or else we are going to output success, and we're actually just going to JSON parse result.text, because the response from the server is an object where when we get user, it will be user with the data, and with the to-dos, it's items with the data. So we can just output that directly. So as I said, error and success are default outputs, but you can define your own, which we're going to take a look at very, very soon. Okay, so now let's say that's okay, and let's import this into our app mounted signal. Okay, so we are going to get the user now, and the path we can choose is something we can define with an object. So after this action, since we know that this will output to paths, we can say success and error. We do not have any actions there yet, but let's just define them like that. And let's see what happens now when we run the application. And as we can see now is that even though we haven't done anything in the UI, we haven't logged anything out, we just implemented the actions, and we can see in our debugger that it actually ran an async action called get, and it had a success, and we can see the output of that success. So now you see how easy it is to do changes to your application without verifying it in the UI or using logging. It's just a natural part of the debugger. Okay, so what we want to do on a success is that we want to set the user, or on an error we want to set user error. We're not going to create that action because it will never be an error, but now it's just to show you how you would do it. So set user is nice because we want to show it in the UI. So let's import set user from actions set user.js. Okay, let's create that before we save it. Set user.js, set user input state.set user data is the path, and now the input will be user. As we saw here, the output is user, and that's the data. So we just use input user, export default set user. And the reason we do not set the user inside the get here, for once it's a generic action, but you cannot do state mutations inside asynchronous actions, and that has to do with how the debugger works, and just generally it's easier to reason about your application if your signal has one action for getting and one for setting. Because if you're getting and setting in the same action, then the action does two different things, and actions should just do one thing. So yes, let's see, set user, app mounted set user. So if we save that now, we should see some more information in our debugger. And as we can see, we have app mounted, set loading true, success, and set user. What we also want to do here is we want to unset the loading when everything's done here. So let's create that action very quickly now. And we insert that after the array, which means that when all this is done, it will unset loading. So let's create that very quickly here. Unset loading. Unset loading JS function unset loading input state. State set is loading to false. Hope I'm not going too fast here now. Unset loading and save that. Save that. And let's see what happens now. And now it says no user, and that's because we set is loading to false and we don't have any logic to display the user. So let's insert that logic now. And we can simply do that by first including some user data here. So the user will be user data, okay? And inside our render user, we can say if we have some props user, we can return div welcome this props user name. That's nice, okay? Let's see what happens now. Fire up the application and it says welcome Christian. Awesome. Okay, so now we have that working, but we also wanted to display some to-dos. So let's first create a second action here. So when you define multiple actions in this asynchronous array, they will actually run in parallel. So let's call to-dos, and let's just create a success on this one, set to-dos. And let's just do this quickly and not spend too much time on it. Set to-dos, set to-dos. Let's see, new file, set to-dos, JS. And let's just grab that one. Set to-dos, and that was to-dos data. Set to-dos and set to-dos. And it should of course be input items here, like that. Okay. So when we refresh now, let's see what happens. And we get an app mounted, set loading. We have two get async. We can see the results. And we are setting the to-dos, and we are setting user here. So this is working as expected. So what we are going to do now is just go in here and say this props to-dos map to this dot render to-do. So let's grab the to-dos here, and that is to-dos data, and as you saw, the initial value of data was an empty array, I hope. No, we said no, sorry. Let's just make it an empty array so we don't have to check stuff. Okay, to-dos data, and now we have the to-dos available here, and we just have to create our render to-do. And it receives a to-do and the index. So let's just return li key is index and just the to-do title here. Okay, and this should of course be inside a UL element like that. Let's save it and see if everything works as we expect. Yeah, and we got some to-dos. Awesome. Okay, so this is some insight into how you create signals and actions. And as you can see, you always have this insight into what's happening inside your application when you run it in the browser, which is really, really nice. But we can secure our signals and actions a bit more. For example, in this case, we, on the success of getting a user, we expect to get a user, and that's an object. And we can secure that so that when, let's see, when we set a user, we can say set user input, and that input should be a user, and that should be an object. Okay, so we are just now type checking the input. So if I save this now, it shouldn't really do anything different. Everything just worked out as it should. But let's go in here now and say that this should not be an object, it should be a string. Let's see what happens now. And now we got an error. So now it states, Cerebral states that you're giving the wrong input to the action set user in signal app mounted. Check the following prop user. Okay, so this is very nice when you work on big applications in a big team. It's harder to go in and ruin each other's code, and you're kind of like securing the signals and their actions. And as you saw here now, I was just using the constructors of JavaScript, but you can use an external type checking library for this stuff. So if this is a function, you will get the value, and you can return true or false if it's the correct type. And this is typically how other type checking frameworks libraries work. So you could, like my type check is string, for example. And that would just work out. But to get going with type checking, you can use basic JavaScript constructors to identify the type. But that quickly does not work out, but it's a lower threshold to get going. You don't have to bring in any dependencies and stuff like that to do it. Okay, so that's the input. But we can also define the output. So if we move into well, now I see that I've done something kind of dumb here because I have a general factory for doing output, so it doesn't work very well to type check the output here, but it works the same way as an input. But what I wanted to show you is that you can verify that you're using you can use different outputs. So now currently we have error and success, and if we were to type check this, we would say get outputs, oops, and we would say error, and we would say, like with the user, we would say object, and sorry, success here. Okay, so on the success, we will say user object, just like we did with the input. There's nothing different here, only that we specify the output. Okay, but instead of type checking the output here, we can ensure that we are using this correctly. So instead of using an object to type check, we can use an array. So let's say success and error should be the outputs here. And if I save that now, and everything should just work. I cannot find. Oh yeah, sorry. And now you actually see what's happening. And it states that in our app mounted signal, there's an action get that cannot find its error path. And that is because if we look into our app mounted signal here, we see that, okay, this get has an error, but this one does not. So if I insert an error here and save it, everything should work again. And this is exactly what I wanted to show you. It's that you can secure the signal by defining the exact outputs an action should go to or should be able to go to. So now it worked again, and this is also a safety check on larger teams and applications. So let's redefine these. Let's say foo bar instead, just for fun. And if I save this now, it should give an error again because it can't find those outputs, and it does. But if I go into our signal now and we call it foo bar, foo bar, and of course we have to change this inside our action 2 and like that. And you can have multiple outputs. It's not only 2, you can have lots of them, because maybe you want to do very different things, like when a server says no access or can't find item or whatever. You can have different paths for that. So here we see we're using foo instead of success. Okay, but this, you can read more about this type checking and all that stuff. As I said, it's more for larger teams and larger applications, but I just wanted to show you that it's possible to do this stuff. So this is actually what I wanted to show you. I hope this gave you some insight to how you can structure your application and how actions and signals actually work. There will be more videos on specific use cases, like handling different kinds of UI with state and stuff like that. But this should get you started. So thanks for watching, and have fun.